The Arleigh Burke class destroyer is one of the most consequential warship designs of the modern era. Since the early 1990s, it has formed the backbone of the United States Navy's surface combatants force, and has become a symbol of American naval power after the Cold War. Designed originally as a high-end escort for capital ships, the Arleigh Burke class has evolved into a highly flexible, multi-role destroyer that performs air defense, anti-submarine warfare, and land attack missions across the globe. More than 3 decades after the first ship entered service, the United States Navy is still building new Arleigh Burkes. That fact alone says a great deal about both the strengths of the design and the persistent difficulty the Navy has faced in replacing it. At its core, the Arleigh Burke class exists to protect high-value naval assets. In traditional American naval doctrine, aircraft carriers are the primary offensive arm at sea. Destroyers are there to defend them. The Arleigh Burke is therefore best understood as a defensive warship first and an offensive one second. Its primary missions are area air defense against cruise missiles and aircraft, and ballistic missile defense for some of the class. Anti-submarine warfare performed mainly by the Burke's helicopters and land attack operations are important secondary roles. However, anti-ship warfare against enemy surface combatants has never been its primary purpose. That role has historically been assigned to carrier-based aircraft and submarines, which can strike enemy ships with greater operational range and flexibility. This doctrinal choice has shaped the weapons, sensors, and overall design of the Arleigh Burke class from the beginning. To understand why the Arleigh Burke looks and operates the way it does, it is useful to look back at the evolution of American surface combatants during the Cold War. For much of the post-Second World War period, the United States Navy built relatively specialized surface warships. Destroyers and frigates were often optimized for a single primary mission. Anti-submarine warfare ships like the Spruance class were designed to hunt Soviet submarines. Frigates, such as the Oliver Hazard Perry class, were cheaper escorts with limited air defense, intended to protect convoys and secondary task groups. Air defense was handled by cruisers like the Ticonderoga class, which carried the Aegis combat system, and the powerful Spy-1 phased array radars to defend carrier strike groups from massed aerial threats. By the late Cold War, this highly specialized fleet structure began to look increasingly inefficient. Advances in sensors, computing, and missile technology, including vertical launch systems, made it possible for a single ship to perform multiple roles at once. At the same time, the Soviet threat was evolving, with longer-range aircraft, cruise missiles, and ballistic missiles posing increasingly complex challenges. The United States Navy responded by moving towards genuinely multi-role surface combatants. The Arleigh Burke class was the most successful expression of the shift. Instead of building separate ships for air defense, anti-submarine warfare, and land attack, the Navy chose to combine all these capabilities into a single destroyer built around an integrated combat system and a flexible vertical launch system for all sorts of weapons. The Arleigh Burke class entered service in 1991, just as the Cold War was ending. However, rather than becoming obsolete with the collapse of the Soviet Union, the design proved adaptable to a wide range of post-Cold War missions. Arleigh Burkes escorted carriers in the Persian Gulf, launched cruise missiles during conflicts in the Balkans, and conducted ballistic missile defense patrols in the Sea of Japan. Over time, the class grew in size, complexity, and capability through a series of evolutionary upgrades known as flights. The class is divided into several major flights, each representing a step in the design's evolution. Flight 1 ships were the earliest variants and established the basic configuration of the class. It has a helipad but no hangar for housing helicopters. Flight 2 followed with modest improvements, primarily in combat systems integration, communication, and signals intelligence. Flight 2A represented a major leap, adding a double hangar to sustain helicopters at sea, and expanding anti-submarine warfare capability as a result. Later sub-variants of the Flight 2A incorporated technology insertions and incremental upgrades. The most recent and most radical variant is Flight 3, which introduces a much more powerful Spy-6 radar and significantly upgraded power and cooling systems. As of the mid-2020s, the United States Navy plans a total of 99 Arleigh Burke class destroyers. 74 are active, with additional ships under construction or on order, all of them Flight 3 variants. In terms of basic characteristics, the Arleigh Burke class is a large destroyer by historical standards. The ships are approximately 155 meters long, with a beam of about 20 meters. Displacement varies by flight, but modern Flight 2A and Flight 3 ships displace around 10,000 tons at full load. Propulsion is provided by 4 gas turbines driving 2 shafts, producing enough power for speeds in excess of 30 knots. Operational range is approximately 8,000 kilometers at cruising speed, allowing the ships to operate globally without frequent refueling. Endurance is typically measured in weeks, although can be stretched out for longer, with crew comfort and logistics being the main limiting factors rather than fuel alone. Crew size has increased over time as systems have become more complex. Early flights carried roughly 300 personnel, while later ships typically operate with a crew of around 320. Flights 2A and later ships include hangars and flight decks capable of supporting 2 medium helicopters, usually the MH-60R Seahawks. These helicopters are critical components of the ship's combat power, particularly for reconnaissance during independent surface actions and for anti-submarine warfare. The ships also carry small boats for boarding operations, search and rescue, and other secondary tasks. Structurally, the Arleigh Burke class reflects lessons learned from earlier American warships. One of the most important design decisions was the return to an all-steel construction for both the hull and the superstructure. Earlier classes, including the Ticonderoga cruisers, used aluminium extensively in the superstructure to save weight. Experience showed that aluminium structures were more vulnerable to fire and heat damage, particularly in combat conditions. The Arleigh Burke's steel construction improves survivability and damage tolerance, even at the cost of increased weight. The hull form and bow design are optimized for blue water operations. The pronounced flare at the bow improves seakeeping in rough seas and helps keep the deck dry at high speed. This is not a ship designed for coastal patrols or shallow waters. It is meant to operate in open oceans, often far from land, in support of carrier strike groups and other major naval formations. Internal compartmentalization, redundant systems, and robust damage control features reflect the ship's role as a front-line combatant expected to survive battle damage and continue fighting. A walk from bow to stern reveals how the Arleigh Burke's layout supports its missions. At the bow sits the main gun, a 127mm naval artillery designed primarily for surface engagements at short range and for naval gunfire support near shore. Immediately behind the gun is the forward Mark 41 vertical launch system, a large array of missile cells embedded deep into the ship's hull. This launcher is one of the defining features of the class, allowing the ship to carry a mix of air defense missiles, land attack cruise missiles, anti-submarine weapons, and ballistic missile interceptors. Flights 1 and 2 possess a total of 90 vertical launch cells, while Flights 2A and above have 96 total missile cells. The superstructure rises behind the forward launcher and houses the bridge, command spaces, and the primary radar arrays. The shape of the superstructure reflects a balance between radar performance and reduced radar cross-section, though stealth was never the dominant design driver. Midships are the exhaust stacks for the gas turbines, carefully designed to reduce infrared signature. Further aft is the second vertical launch system on most variants, followed by point defense weapons, and on later flights, the helicopter hangars and the flight deck. The flight deck, to be clear, is available on all flights, but not the helicopter hangar. At the heart of the Arleigh Burke class is the Aegis combat system. Aegis is not just a radar or a fire control system. This is an integrated combat management system that links sensors, weapons, and command functions into a single network. Its original purpose was area air defense, detecting, tracking, and engaging large numbers of incoming aircraft and missiles to protect a carrier strike group. Over time, Aegis has been upgraded through successive software baselines, each expanding its capabilities. Early versions of the Aegis focused on traditional air defense against aircraft and cruise missiles. Later baselines added ballistic missile defense, cooperative engagements with other ships and aircraft, and improved integration with land-based sensors. The latest baselines are designed to manage multiple types of threats simultaneously, without forcing the ship to prioritize one mission at the expense of others. This evolution has allowed the Arleigh Burke class to remain relevant as threats have become faster, stealthier, and more diverse. Area air defense is the defining mission of the Arleigh Burke class. This role is built around the Mark 41 vertical launch system and a layered family of guided missiles that allow the ship to protect itself and nearby forces over wide areas of ocean. The standard missile family forms the backbone of this capability. The Standard Missile 2 provides medium-range defense against aircraft and cruise missiles, using semi-active radar guidance that relies on the ship's radar to illuminate the target during the terminal phase of engagement. The more modern Standard Missile 6 extends this envelope significantly. It offers longer range, higher speed, and the ability to engage highly maneuvering and high-altitude threats, including some ballistic and hypersonic targets. Unlike earlier missiles, it uses an active radar seeker, allowing it to operate more autonomously and engage targets beyond the radar horizon through networked targeting. For short-range air defense, the Arleigh Burke class relies heavily on the evolved Sea Sparrow missile, a compact and highly agile interceptor designed to defeat sea-skimming cruise missiles and other fast maneuvering threats. One of its most important advantages is its smaller size compared to the standard missiles, which allows 4 evolved Sea Sparrows to be quad-packed into a single Mark 41 vertical launch cell. This significantly multiplies the number of defensive interceptors a destroyer can carry, without having to increase the number of launch cells available. In practical terms, this gives the ship far greater resilience against saturation attacks, where an adversary attempts to overwhelm defenses by launching large numbers of strike missiles simultaneously. The evolved Sea Sparrow missile uses different guidance systems, including inertial navigation with mid-course updates and an active radar seeker in its latest variant, allowing it to engage targets on its own without sustained fire control in the terminal phase. By combining high maneuverability with dense magazine capacity, the evolved Sea Sparrow forms a crucial inner layer of the Burke's layered air defense. For ballistic missile defense, selected Arleigh Burke class destroyers are equipped to fire the Standard Missile 3, a specialized interceptor designed to engage ballistic missiles during the mid-course phase of flight outside the atmosphere. Unlike traditional surface-to-air missiles, the Standard Missile 3 uses a kinetic kill vehicle that destroys its target through direct impact rather than an explosive warhead. This gives the Burke a unique ability to engage ballistic threats. Over time, this capability has transformed parts of the destroyer fleet into a central pillar of regional missile defense architectures, particularly in the Pacific and in Europe. The relevance of this capability has grown sharply in response to China's expanding inventory of anti-ship ballistic and quasi-ballistic missiles. Land-based systems, such as the DF-21 and DF-26, are explicitly designed to hold aircraft carriers and large surface combatants at risk over long distances, while newer systems like the DF-17 employ hypersonic glide vehicles that further compresses reaction time and complicates interception. At sea, the emergence of ship-based weapons such as the YJ-20 anti-ship ballistic missile extends this threat into the maritime domain. In this context, the ability of Aegis-equipped Burkes to detect, track, and potentially intercept ballistic trajectories provides the fleet with at least a partial defensive counter to weapons intended to deny access to contested regions. While not a complete solution, Standard Missile 3 gives the US Navy some means of contesting the ballistic layer of China's anti-access strategy. Across most of the Arleigh Burke class, from Flight 1 through Flight 2A technology insertion ships, the primary air search and targets tracking radar is the AN Spy-1D radar. This is a passive, electronically scanned array radar operating in the S-band, optimized for long-range volume search, targets tracking, and missile guidance in a naval air defense environment. The radar consists of 4 fixed panel arrays mounted high on the ship's forward superstructure, arranged to provide continuous 360-degree coverage without mechanical rotation. The Spy-1D was a major advance when introduced, allowing a single ship to track hundreds of targets simultaneously and guide multiple missiles in flight through the Aegis combat system. The later Spy-1DV variant improved performance in littoral environments by enhancing resistance to clutter and electronic interference. Despite these refinements, Spy-1D remains constrained by its passive array structure, which means that a single transmitter generates the radiation signal. Fundamentally, this mechanic can only form a single primary beam at any one time, even if the array element can steer that beam very quickly. If the single transmitter fails, the radar is incapacitated. Flexibility, sensitivity, and jamming resistance are therefore structurally limited. Flight 3 Arleigh Burke destroyers replaced Spy-1D with the AN Spy-6 air and missile defense radar, representing the most significant sensor upgrade in the class's history. Like Spy-1D, Spy-6 uses 4 fixed arrays mounted on the superstructure, but the similarities end here. Spy-6 is an active, electronically scanned array radar built from modular radar assemblies using gallium nitride semiconductors. This means the Spy-6 distributes large numbers of transmitters across the entire array. Each antenna element has its own transmitter and receiver modules built in, and can generate and process its own signal. This allows the formation of multiple beams simultaneously in different directions. This shift dramatically increases radar efficiency and sensitivity, although at the cost of greater power and cooling requirements compared to the Spy-1. There is also no single point of failure since there are many transmitters, leading to a more robust and jamming-resistant system. Additionally, the Spy-6 apertures on the Flight 3 Arleigh Burkes are larger than the Spy-1D apertures in preceding flights. Even setting aside the structural advantages of the active, electronically scanned array, a larger size generally means a larger number of antenna elements, which means detection at greater ranges and vastly improved discrimination of targets. Furthermore, the Spy-6 allows simultaneous high-fidelity tracking of aircraft, cruise missiles, and ballistic missiles without forcing trade-offs between missions. Where Spy-1D often required prioritization between air defense and ballistic missile defense, Spy-6 is designed to do both at once. Anti-submarine warfare is another critical mission, and here the Arleigh Burke relies heavily on its MH-60R Seahawks helicopters. Ship-mounted sonars are limited by the noise of the ship itself and by water conditions. Seahawks can deploy sonobuoys, dipping sonars, and torpedoes over a wide area, dramatically extending the ship's reach. The destroyer's own sensors include a bow-mounted sonar and, on later variants, a towed array sonar that trails behind the ship. This towed array is particularly effective for passive detection at long range, as it is isolated from the ship's own noise. When a submarine is detected, the Arleigh Burke has several options. It can launch ASROC anti-submarine rockets that carries a lightweight torpedo to the target's area, or it can rely on its helicopter to prosecute the target. The combination of sensors, helicopters, and weapons makes the Arleigh Burke a formidable submarine hunter, especially when operating as part of a coordinated task group. Land attack capability is provided primarily by the Tomahawk cruise missile. This weapon allows the Arleigh Burke to strike targets hundreds or even thousands of kilometers inland with high accuracy. Modern variants like the Block 4 Tomahawks can be reprogrammed in flight and retargeted based on updated intelligence. This has made the class a key tool for early strikes in many conflicts, allowing the Navy to project power without exposing aircraft or pilots to immediate danger. The main gun can also provide limited fire support close to shore, though its range and effect are modest compared to missiles. Points defense represents the final protective layer for the Arleigh Burke class when all other defensive measures have failed. Most ships are equipped with the Phalanx close-in weapon system, a radar-guided, rapid-firing gun designed to destroy incoming missiles at extremely short range. Phalanx operates autonomously, reacting in seconds to fast, low-flying shreds that penetrate outer defensive layers. Some Burkes instead carry the CRAM system, which replaces the gun with short-range rolling airframe missiles, offering greater engagement range and improved performance against highly maneuvering targets. While neither system represents the most modern approach to points defense when compared to newer gun and missile hybrids, they remain reliable and combat-proven as a last-ditch safeguard. In addition to hard-kill systems, Arleigh Burkes employ soft-kill measures such as chaff and flare decoys, which are launched to confuse radar and infrared-guided missiles. Together, these points defense systems provide a critical final barrier, increasing survivability in highly contested environments. Anti-ship warfare is the area in which the Burke is weakest, and this is largely the result of design choices. Early flights carried Harpoon anti-ship missiles, which offered modest range and subsonic speed, and are now considered obsolete against modern air defenses. While Harpoon provided a basic surface strike capability, it was never central to the Burke's mission. In recent years, some destroyers have begun to receive the Naval Strike Missile, which offers improved stealth features and terminal guidance, but deployment remains limited. The Tomahawk has partially re-entered the anti-ship role through its Block 4 and Block 5 variants, benefiting from in-flight retargeting and more suitable seekers for moving targets like warships. Even so, Tomahawk remains a subsonic weapon optimized for land attack, not a high-speed maritime strike missile. Compared to the hypersonic and supersonic weapons fielded by Chinese and Russian surface combatants, the Burke's anti-ship firepower remains constrained. Electronic warfare has become a central element of naval combat, and the Arleigh Burke class has undergone major upgrades to reflect this reality. In the early 2020s, selected ships began receiving the Surface Electronic Warfare Improvements Program Block 3, formerly designated the AN/SLQ-32V7. This system significantly improves the ship's ability to detect, classify, and counter hostile emitters across the electromagnetic spectrum. Using advanced electronically scanned arrays, it combines sensitive passive surveillance with powerful active electronic attack, allowing the ship to disrupt enemy radars, data links, and missile seekers. Installing this capability required major structural changes, including large enclosed extensions to the superstructure that gives upgraded ships a noticeably bulkier appearance. Control of the electromagnetic spectrum is now as critical as control of the air or sea. For the Arleigh Burke, electronic warfare has evolved from a supporting function into a core contributor to survivability and overall effectiveness. given that the US Navy is clearly cramming a large amount of capabilities into an increasingly limited space, it is natural to ask why the Navy continues to build Arleigh Burkes instead of replacing them with a new destroyer. The answer is both simple and troubling. No suitable replacement is ready. The Zumwalt class was intended to be the future of the American surface fleet in the 2010s, but it suffered from cost overruns, cancelled systems, and unsuitability for actual naval warfare. The Constellation-class frigate was supposed to fill the gaps between large destroyers and smaller ships, but it was recently cancelled after years of design problems and cost growth. As a result, the Arleigh Burke has been forced to do everything. It conducts high-end air defense and anti-submarine warfare, but it is also used for routine patrols, presence missions, and escort duties that could be handled by cheaper ships. This creates the reality of overstretch. High-end destroyers are expensive to operate and maintain, and using them for lower intensity tasks reduces their availability for the missions they are uniquely suited to perform. Looking ahead, the Arleigh Burke class will eventually need to be replaced as the earliest ships approach retirement in the 2030s. For several years, the US Navy's intended successor was the DDG-X program, a next-generation destroyer designed to move beyond the physical and electrical limits of the Burke hull while preserving its core role as a multi-mission escort and air defense combatant. DDG-X was conceived as an evolutionary step, a larger hull with greater power generation, improved sensors, and growth margins, but still recognizably a destroyer optimized for fleet operations. That pathway is now increasingly uncertain. There is a risk that DDG-X could be displaced or effectively cancelled in favor of the proposed Trump-class battleship, formerly designated BBG-X. This represents a radical departure in scale and concept. At over 35,000 tons, the Trump class would be closer to a capital ship or large cruiser than a destroyer, concentrating firepower, sensors, and command functions into a very small number of extremely expensive hulls. Replacing DDG-X with BBG-X would introduce substantial development risk, given the Navy's recent struggles with complex new designs, and operational risk by reducing fleet numbers and flexibility until enough battleships become available. There are a lot of experimental and unproven systems in the current Trump-class design, such as railguns and hypersonic missiles, which of course carry development risk. Furthermore, a small number of massive ships cannot easily substitute for a larger population of destroyers capable of escorts and independent actions. If the Trump class replaces the DDG-X as the Arleigh Burke successor, the Navy would risk trading a much-needed practical Burke replacement for an ambitious but potentially brittle solution that may arrive late, over budget, or not at all. The influence of the Arleigh Burke design extends well beyond the United States, shaping the surface combatants' fleet of several key US allies. Japan has adopted the Burke concept more directly than any other nation, operating multiple classes derived from the original design. The Congo and Otago classes closely mirror early and Flight 2A Burkes, optimized for area air defense and later adapted for ballistic missile defense in response to regional threats. The newer Maya class goes further, incorporating advanced combat system upgrades and improved cooperative engagement capabilities. South Korea has taken the concept in a different direction, with the Sejong the Great class. These ships are significantly larger than the standard Burke, displacing over 10,000 tons and carrying a much larger missile load, including additional vertical launch cells dedicated to strike missiles. Collectively, these designs demonstrate how the Arleigh Burke has become a global reference point for modern multi-role destroyers in the West. In conclusion, the Arleigh Burke class was a revolutionary design when it entered service. It marked the United States Navy's full transition to multi-role destroyers capable of defending fleets, hunting submarines, and striking targets ashore. Over more than 30 years, it has proven reliable, adaptable, and effective. That success explains why the Navy continues to build and modernize the class. At the same time, this reliance is a warning sign. No warship, however successful, can serve forever as the backbone of a global navy. The future of American naval power depends not on how long the Arleigh Burke can be stretched, but on whether a credible, affordable, and timely successor can finally be built.